Hello and good day, pre-algebra. Here with you to go over math packet number 7. Kind of introduce each question, give you some tips, some formulas as you work through it on your own. This packet is due February 16th, so today is the 5th? So you got about a week and a half left to finish that up, a little bit more. So the first one here, the Brookfield Badgers are competing in a grueling 12-mile relay race. Coach Thompson met with a 4-member team and gave them the following instructions. Martin will run 1/4 of the entire distance. The next third of the distance will be run by Ben. Corey will cover half of the remaining distance. Jason will run the rest of the way. And the question is, who runs the furthest? Okay. And for this particular question, reading and the wording is very important. Okay. Because when we talk about Martin running 1/4 of the entire distance, well, 1/4 of 12 is 3. And then if you think about it as the next third of the distance will be run by Ben, if you take a third of 12, which gives you 4, and then Corey cover half of the remaining distance, if you take half of 12, which is 6, you quickly see here that you run into a problem, right? That if Martin runs 3, Ben runs 4, and Corey runs 6, well, already we're up to 13 miles. The race is only 12, and Jason hasn't even run anything yet. Okay, so we can't just look at the fractions and take a fourth, a third, and a half of 12. Martin running 1/4 of the entire distance, that is going to be 3. But then it says the next third of the distance. The next third of the distance. So if we kind of map this out, here's mile 0, here's mile 12, okay? Martin runs 1/4 of the entire distance. We know that's 3 miles there. The next third of the distance is run by Ben. We've got 9 miles left here. So when you take that, the next third, it's going to be a third of 9, not a third of 12. Right? And then for Corey, it says he will cover half of the remaining distance. Again, not of the original 12 miles, but of what remains after Martin and Ben run. And then Jason will run the rest of the way. So read very carefully, and it might help you to map it out, kind of like I did down below here. Just graph it out, and you can see, make sure you're following the directions carefully. Next logic question. What do we got here? Create a data set with 5 values that will have a mean of 20. Of course, we know that mean means the average. So we'll add all 5 of the numbers together and divide by 5, and that will give us 20. A median of 18. We know that a median is the number in the middle when ordered from least to greatest. We can already fill that 18 in. We know it's got to be there in the middle. Okay. And a mode of 15. Mode means it repeats, it shows up most often. So we know that 15 has to appear here more than once. And if these numbers are ordered in least to greatest, which is how we know that 18 is in the middle there, being the median, if there are more than one 15, well, those two 15s got to come before the 18 if we're going to order these in least to greatest order. So really, your task, we have 3 of the 5 numbers accounted for and in their right positions. Your task is to figure out what 2 numbers are we going to be using to complete this data set to make the average 20. Okay, which again, that means you're going to add all 5 of the numbers together and divide by 5 because that's how many there are. So all of these numbers added together and all of them divided by 5, that has to equal 20. So you got to figure out what 2 numbers would you add to the set to make that happen. Then we have the 5-card challenge. No real challenge here when you got that 1. Okay, you can use that in so many different ways to get what you want or get more points, because you can multiply something by 1, divide by 1. You could take something in the power of 1, and it's not going to change the value of that number. So a very handy dandy ace there to help you with this one. Next up, we have find the area of the shaded region. This the question is new to you as far as the math packets are concerned. Packets 1 through 6, you always needed to find the perimeter and the area of a figure. Now you're looking for shaded area. And like we talked about in class, the way this is set up here, having you find the area of the entire figure and then the shaded region, it's kind of a game plan for you. Because if you look at the entire figure, which is a rectangle, right? And so the area of the entire figure is going to be base times height, or 10 times 7, which is 70. Okay, that's what we're starting with. Now, if we remove the area of this white square and remove the area of the white circle by subtraction, what we're left with is this area of the shaded part. So it's kind of like a birthday cake. If you get a birthday cake that is 7 by 10 inches and you take a big chunk out of the middle in the shape of a circle, in the shape of a square, you remove those pieces, what you're left with is all this other stuff. And that's actually what we're trying to find here. So our game plan is going to be that 70, which represents the area of the entire figure, and we're going to subtract the area of the square and subtract the area of the circle. And the number that we're left with, what's left over, will be the area of the shaded region. Okay, so we know the area of a square based on prior packets and prior work is base times height. And we know the area of a circle is pi r squared. So you can take it from here. Okay, you can take it from here. If you aren't using the pi button on your calculator, then you can just use 3.14 as an approximation. Next question, the pattern block question. Okay, so this one, we can see that we're building this pattern with squares. We start with just a single yellow block. In figure 1, there's one yellow block, there are no red blocks, and the total number of blocks is just 1. Okay. In figure 2, there's still one yellow block, and you can either count those red blocks up to get 8, there are 8 of them there, and you can add 1 and 8 to make a total of 9, or you could recognize that, hey, this is a 3 by 3 square here, and the area of a 3 by 3 square is going to be 9. You look at figure 3, and you see there's one yellow. You could count up all those red ones. It's starting to get a little bit more challenging just because there's more of them. Or you could recognize that this is a 5 by 5 square, which means there are 25 total blocks. If one of them is yellow, that leaves us with 24. In figure 4, still that solitary yellow one. This one is a 7 by 7 square, and it's at this point that probably, realizing it's a 7 by 7 square, which is an area of 49, and subtracting that yellow block to get 48 red ones is going to be faster than counting up all those red ones by themselves. Okay. And now we go to the part of the table that's not here for you, where you need to continue this pattern for other figures. Because as I've said from the start, if your process here is to make figure 5, draw figure 5, and draw figure 6, 7, and 8, with this pattern especially, they're starting to get kind of big. Okay, and so looking at these patterns is the much preferred method. We can be confident there's only one yellow block in the rest of the figures there. And then the total blocks is actually where we're going to go next, because like we talked about in class, notice here there's one total block. We had a 1 by 1 square. 3 by 3 square gave us 9, then a 5 by 5 square, then a 7 by 7 square. Okay? So we can predict that figure 5 is going to be a 9 by 9 square, which is going to have an area of 9 squared, or 81. One of those blocks is yellow, which means that 80 of them are going to be red. Okay? So that kind of gets you going. This is definitely a pattern with squares, and that's why these perfect squares, 1, 9, 25, 49, 81, are such an important part. Don't worry about this bottom part here. That's for geometry only. You don't need to fill that out. You are only going through figure 8 through figure 8. Next up, surface area of a sphere, the last figure that we are going to talk about with surface area. The last new figure, we'll talk about it. So we drew a net of the figure in class, and we talked about how a sphere, it's widest in the middle. That's why we have that special latitude line of the equator. Balls are thickest, right, at their center. And then as you go up towards the top of the sphere or down towards the bottom, it kind of tapers off, which when we draw the net of this, it's going to be kind of like 4 leaf-shaped figures. And remember, I got a D in art growing up, so please forgive my lack of artistic talent here. Not too bad, I guess. But that red equator measurement that I highlighted in the sphere, that's going to be going across the center of this right through the middle. And that's why all of those connect, okay, because that's its widest point. And then as we go towards the top, it kind of tapers off. We got those spaces that we see in there. And as it goes down, it kind of tapers off too. We lose surface. Yes, I am. So,
We'll come back.
okay.
How long would it be?
I'll be done about 3:35.
Okay, we'll come back.
Okay. And so as you go up towards the top of the sphere, down towards the bottom of the sphere, we lose surface, and that's why you've got these spaces here within the figure. Okay, and the formula for surface area is 4 pi r squared. So similar to area, but the coefficient of 4, surface area 4 pi r squared, and you need to calculate what the surface area of that is. There we go. Okay, next one, we got volume, also of a sphere. And the formula for the volume of a sphere is 4/3 pi times the radius cubed. Or another way that you could write that is 4 pi times the radius cubed divided by 3. Okay, both of those formulas achieve the same thing, that's written a little bit differently. To find the volume of this particular sphere with a radius of 9, I'm going to use the second formula here that I wrote down. So it's 4 pi times 9 cubed divided by 3. And the volume of that figure, I've done this about 18 times now with all the different classes and everything. You think of it, it's 3,053 something. I don't remember what the decimal is. 3,053.63. Okay, and again here, since we're involving pi, if you use the exact value of pi versus a rounded one, your answer might be a little bit off. And when I say off, I'm talking like off by 1. Maybe you got 3,052. Okay, if you're off by 10, that's a problem. If you're off by 100, that's a problem. If you're off by 1,000, that's a big problem. Okay, but this is what you come up with for the volume. And then for pre-algebra here, it says a rubber sphere with a radius of 3 centimeters is put inside the original sphere. What percentage of the original sphere's volume remains available? So we've got our original sphere here with a radius of 9. And inside of this, we put a rubber sphere, okay, with a radius of 3, which obviously takes up some of the space that's inside of the original sphere. And so the question is, if you do that, what percentage of the original sphere's volume, which is all this other stuff, I feel like I'm making a Pokemon here or something, all this other stuff, all this other space that's not used up by that radius of 3 rubber ball, what percentage of the original sphere is that? So the game plan that we came up with in class was you need to find the volume of your original sphere, which we found to be 3,053.63, and you're going to subtract the volume of your smaller sphere that has that radius of 3. Okay? Looks like an angry Pac-Man or something with his mouth shut. But anyway, so the original sphere volume minus the volume of that smaller sphere, and then to find the percentage of the original sphere's volume that remains available. Remember that percent is equal to part divided by whole. So when you subtract the volume of that smaller sphere to get the part of the original sphere that remains, that number is going to represent your part. Okay, so this calculation will get you the part of the original sphere that's left, and then you're going to take that number and divide by the whole, which is the volume of the original sphere, which we already got to be 3053.63. Okay? That was kind of the game plan that we talked about. We're going to find the volume of the new sphere, subtract it from the original sphere to get the volume that remains in the original sphere, and then divide that by the original volume to get the percentage that remains. Okay. Next one, writing the Fibonacci numbers. We spent the first 6 packets talking a lot about Pascal's triangle. Now we're going to be talking about Fibonacci, which is another pattern that's at its core is very simple, but the mathematical implications and just the life implications that it has are phenomenal. And the pattern is this. Basically, every number in the sequence is the sum of the 2 numbers before it. So this 2 came from adding 1 and 1 together. The 3 came from adding 1 and 2 together. So the next number in the sequence is going to be 2 plus 3, which is 5. And then 3 plus 5, which is 8. And then 5 plus 8, which is 13. 8 plus 13 is 21. 13 plus 21 is 34. And so on and so forth. And your job, your only job for this packet, our introduction to Fibonacci sequence, is to continue filling out this sequence, these blanks, until you get to the end. Obviously, the sequence continues on and on and on and on and on, but I think the first dozen or so terms is plenty. Okay? Next one, mean, median, and mode. You know, a couple packets ago, I asked you to track the number of hours of sleep you got each evening and find the mean, median, mode. Now I'm looking for your screen time. And so I've got 4 devices listed here: phone, tablet, computer, and TV. And for 7 consecutive days, or if you turn your packet in early and it breaks up your 7-day sequence, just 7 days, record the number of minutes you spend on each device. And you'll find the mean, median, and mode for each of them. Okay. Some questions that have come up. What if I don't have a tablet? Well, if you don't have a tablet, then you're going to be putting a lot of zeros here, right? That's okay. You know. What if do I count the time that I'm spending on my computer when I'm at school? Yes. Okay. And I know you've got a lot to think about when you're at school anyway, let alone tracking how much time you're on your device. So there's a little bit of leeway here. Like if you're taking a science quiz and it takes you the entire period, well, then that's 45 minutes on your computer. If you finish a couple minutes early, then maybe you put 40. Okay. I'm not looking for 37 minutes today and 2 minutes. It can be a little bit of rounding there. If you're playing video games, are you playing them on the computer? If you are, that counts for computer. If you're playing where you're watching the action on the TV, that counts for your TV. If you've got a Switch and you're holding it and playing it like that, then that would actually be considered a tablet. Okay, so you're finding the mean, median, mode for each device, and then it says how many total minutes of screen time do you average per day. So when you're done recording the data, you're going to add your 4 means together, okay? And that will give you the total minutes of screen time you averaged per day, and that answer goes down here. And last but not least, our polyomino question. Each of the 8 given polyominoes is used once to make the large figure on the right. A polyomino appears in the diagram exactly as it is shown on the left. Identify where each polyomino appears in the diagram by clearly shading it or outlining it. You must identify every polyomino to receive credit. So you've had ones like this before. You can use those context clues to help you. There are certain figures that can only appear in certain places. I'm looking at just immediately here the polyominoes that have 3 blocks going up, they can't fit here or here, right? So I kind of narrowed it down a little bit for you. I'm not saying that this one's guaranteed to be right here, right? It could be part of something else, but you can definitely see where they can't go, all right, so there you go. That is packet number 7. It is due February 16th. Please consider turning it in early so I can look it over, make any corrections, and you can fix it before the due date. But that is how you math. Don't forget to like and subscribe, and have a great day.